So yeah, this is going to be my focus today. I'm going to be providing explanations of test-driven development. One thing that I do want to experiment with today is let's write the questions as comments, and then at the end of the presentation, we can go over the questions. I usually go for the answering questions as the talk goes, but just for this one today, I prefer to leave the questions for the end, if that's okay. All right, so yeah, I am Felipe Flor. I am a software developer at Vehikl. And amongst the different things that we do at Vehikl, test-driven development is one of the core actions that we follow. And for those who don't know, what test-driven development is this methodology of developing software that revolves around you spending some time to write your tests. So this is the amber light in here. Then once your tests are done, you're probably going to see them failing. So you're in the red stage. Then you're going to be doing the least amount of work necessary to get that test to pass. And so you get to the green light. And once you're in the green light, you start refactoring your code to make it easier to understand. Then you go back, you write another test, you see it fail, you make it pass, you make it better. So red, green, refactor, red, green, refactor. This is the cycle that developers that follow TDD employ. So I absolutely love test-driven development. And I think you should love too, because regardless if you're like where you stand over the development life cycle of the application, TDD benefits you. And I think a good way for us to exemplify this is to imagine a project without tests. I have a friend that he works at a company that don't write any tests, and he sent me like actual footage of his development team, and looks something like this. No, I'm just kidding. But it's not like that, but it does have some horror stories to tell. And I'm going to be sharing some examples in here. And maybe you're not going to be identifying with every single one of them, but I think some people here could relate to one or more of these stories. I can definitely relate to some of those. So as a developer, if I'm working in a code base that doesn't have any tests and I have new work to be done, I have that weird fear of like, am I going to break something if I write this code over here? Especially if that code base was written by someone who is no longer part of the team. So there is like that code in there that I don't understand exactly what it's doing. And the ticket in Jira is asking me to do X. If I do this X thing in this controller, is that going to break the Y thing that is happening as well? I don't know. And like maybe if I remember every single goal that this application had, I could go to the browser and test it myself. But we are humans, and we forget things. So I'll always be afraid of breaking something. Another thing as well is that if I'm new to that code base, I probably don't quite understand what is the purpose of the things in there, like what are the goals of the elements of that application. So that it can make my life pretty stressful working in a code base like that. And a friend that is DevOps, they're going to have their stressful moments too, because every time that a new thing is about to be sent to production, they're going to be asking themselves, like, is this going to break things? And especially on their side, if they weren't there working on the development of those new features, maybe they don't even know for sure what's coming in to what is about to be deployed. And nobody likes getting calls of ours because production is broken right now and we have to fix that right away. It can be pretty stressful for the DevOps. On the project management side, like maybe the development team, like you asked them to do X, they replied back saying, yeah, X is done. And then when the demonstration of the application comes up, it's actually not X that the application is doing. The application is doing Y or Z. So there was some misalignment in there, and you didn't realize that because by the time that you saw it, it was already too late, right? There are like those expectations that are not entirely clear in that project. And then people are going to be shifting blame between one and the other, and that creates that feeling of like conflict, which it's really not cool to have in a work environment. On the quality assurance side of things, maybe you provided feedback, you identified a bug, and every now and then that bug comes back. Like you could swear you told the team, like, hey guys, I see that modal popping up when it shouldn't. Could you get that fixed? And it's fixed for a week, but later the modal shows up again. Like, what? Are they not like listening to my feedback? Like, what's going on, right? That could create that feeling that the feedback that you're giving is just being lost in the vine down the line. And then, okay, now let's consider a project that is following test-driven development. And what I mean by that is a project in which every single feature that is implemented there has a test behind it, protecting the requirements of the application. So on the side of a software developer, not only I'm going to be safer in regards to if I make a change, my tests are going to tell me right away whether or not I broke something in the past, even if I haven't worked in those requirements at all. Maybe my friend Adam worked in that controller, and now he's no longer working for that project. And I assumed that project, I wrote the new feature, and the thing that Adam did, I broke the thing that Adam did. I'm going to know that right away without me having to ask Adam to come in and check into the code. There is this live feedback over the progress of the application. Also, if I'm brand new to the code, I can also just read my tests, and the tests are going to act as an amazing documentation file for me. So I can see what are the rules of the game, like what are the responsibilities of the elements in that application, right? Like of the parts involved. So it can be easier for me to understand the scope of things without actually having to be reading code itself. Our friends on the DevOps side, maybe they can have continuous integration set up. So every time that someone opens a PR to hope to have a new feature being deployed, the tests are going to be running automatically. Right away, you're going to know, oh, that PR right there, that's going to break the modal thing that we're talking about. So we're going to have to get that fixed first. And because of that protection, that also reduces their stress with handling hot fixes. For those who don't know, what I mean by hot fixes is anytime that you have to fix a bug live in production, that's what I call a hot fix. If you have strong protection by tests, the need for that is going to be reduced. On the project management side of things, the tests, the list of tests, the list of specifications that your application contains is effectively a live and objective checklists of what goals were done. So you're going to have objective feedback about where the project is right now. And also, just by reading the name of the tests, you can see what are the specifications that are being enforced. Communications are cleaner now. On the quality assurance side, if you identify a bug, you can explain to the development team how to reproduce that bug. And as long as that test is there, that bug, at least in the way that the test is reproducing it, is not going to be coming back, because the test is going to be preventing that bug to return in that format. So your feedback is actively creating a barrier against that bug in the application. And of course, the end user, a user that uses an app that doesn't have as many bugs is a happy user. So I also added a slide in here just because, yeah, that's also another person who wins by have tests. So I'm painting this picture here that one of the challenging things when we're talking about software development is not learning the programming language. Honestly, I think learning the programming language, how you define for loops, how you define if statements, that's a thing that we can all do with some hours of study. The challenging thing here is being able to do the right thing and be able to do that right thing reliably. And it's by writing those tests that you're going to be protecting that. You're going to have tests anyway, regardless of the project that you're working on. But the question that you want to ask yourself is, are those tests going to be automated? Or am I going to have to do manual work every time to test my application? So I'm going to be showing today how having automated tests behind every feature is one of the best things that you can do to have solid applications. Because as I mentioned earlier, by having a strong test suite, you're going to have shortened the feedback loop over every single design decision that you do in your app. All right. So I've been talking a lot of like, wow, tests are awesome. That's trust me, everyone. Like I know that's kind of maybe I'm selling snake oil. So I want to prove that to everyone here. And so what is the plan? You probably heard about a game called Wordle. So Wordle is a online game maintained by the New York Times. And the rules of the game are effectively every day they come up with a word, 5-letter word that you have to guess. And you have 6 tries. And every time you make a try, they tell you whether the letter that you've picked is in the correct place by marking it green, or it's totally does not exist in the word, so they mark it gray, or it does exist in the word, but it's just in the incorrect location, which is yellow. So the more guesses you make, the more hints you get. So it increases the odds that you're going to be guessing the right word eventually. So we're going to be making this application from scratch together today. And over this entire process, I'm hoping that you're going to be able to see what is the mindset of someone who is following TDD. Every single requirement of this application is going to be driven by tests. Okay? Also, just a heads up, in these examples, as I explained, like every Wordle game has a hidden word that you have to guess. The right answer for the examples that I'm going to be doing today is going to be tests, because I think you can never go wrong with tests. I'm pretty proud of this joke. I'm sorry. Okay, I'm going to continue. So the application is going to start from a very basic one that looks like this. So it's just I'm typing the answer, and if I guess it correctly, it shows you won, like a very basic application. Choose something that looks like this, which it's closer to what the Wordle game is like, and you can make multiple guesses, and eventually you make the right guess, and bam, there you go, you won the game, right? So we're gonna be getting to this point today. One thing to keep in mind, though, is I am going to be focusing more on the mentality behind of things. So we're not going to be going into too much details on how I wrote the Vue 3 composition API implementation of the application. I'm just going to be talking about the tests and the mentality behind them. Another thing that I want to mention as well is that I do realize that a Wordle game is a significantly simpler project than what we, as people who work in the software development industry, have to work with in our day-to-day. But this is intentional. The mentality is still the same, regardless of how complex the project is. And it's by having a simpler project that I can have you focused more in the mentality that I'm using to write those tests. So it's not about solving the puzzle on how to get a Wordle game working. It's more about how do I think about my tests as I'm working towards having a complete Wordle game. Okay, so I'm back to this slide, right? So over this explanation over here, I'm explaining why I really like having tests in my app. And I hope that as this talk progresses, more and more people are going to be joining this family of people who love to have tests in their app. So if at least one of you didn't like writing tests before, and now is, and by the end of this talk is going to be feeling compelled to write tests, that's going to make me the happiest person in the world. One more thing that I want to mention is there are different ways for you to classify tests. When we're talking about the scope of the test, I like to think of 3 different classifications. There are unit tests, feature tests, and end-to-end tests. And they all serve a purpose. But in a way, just to briefly explain this, an end-to-end test, you're effectively creating a bot that imitates what a real user would do to use their application. And this is by far the test that is at the most high level, as in like the test doesn't know much about the implementation, but because it's a bot that is visiting a website and clicking on the things for real, those tests take significantly longer to run. A unit test is the other opposite. In a unit test, you're effectively isolating a piece of code and testing just that. But for you to be able to do it, you're going to be needing to know what are the collaborators of that piece of code and how is this piece of code supposed to collaborate with them. And that makes the unit test be the type of test that know the most about implementation. And as you're going to be seeing today, the more your test knows about implementation, the harder it's going to be for you to be refactoring your code base. On a mid-level between the end-to-end test and the unit test, there are the feature tests. And what I consider a feature test is a test that knows some about the implementation. So for example, today, I'm using Vue 3 composition API to write the application. My feature tests know I'm using Vue. To write those feature tests, I'm using Vue test utils to get those tests done. So those are my tests knowing some about the implementation. But that's okay, because at least like those tests are going to run significantly faster than end-to-end tests, and they'll also be protecting like specific user stories, as I'm going to be showing us today. One thing to keep in mind is that when I'm following TDD, the default approach that I use is I write feature tests. And then if I want to have a specific function under test or something like that, then I'm going to write a unit test for that function. Or if I want to have a specific user story fully driven by a bot representing it, then I can backfill an end-to-end tests. But as you're going to see in this talk, the process that I follow when I'm creating an application is that I go for feature tests as the starting point. Okay, so it's going to be a series of feature tests being used in here. Okay, so now we're in a good point to actually start making the Wordle game. And as you take a look in here, I started this project by using the Vue CLI. And what the Vue CLI does for us, it actually gets our project going with tests out of the box. But I wrote a quick test in here that is what we call a smoke test. That it's not actually like I just want to see if things are working. And you can see that the test did pass. And then as soon as I saw the test passing, I just deleted the whole application. Because none of that hello world component matters for my Wordle game. That's what we call clutter, right? So I just got rid of it. And now we're in a good point to begin. So as I mentioned before, we're going to be following this approach of write a test, see it fail, make it pass, and then make it better, and keep repeating over and over again. So when I'm talking about a Wordle game, when we're creating the game, I should be able to set what is going to be the right answer. Like, what is the person supposed to be looking for to win the game? And right now, I'm not even going to be talking about winning the game at all. I just hope that my app can take into account a right answer. And I did get a test over here written for it. Again, I'm not going to go into details on how Vue test utils work. I just want you to focus on the overall idea of the test. So I'm just creating an app, I'm providing a right answer to it, and I hope the app didn't break. And this test is passing right away. I didn't actually even need to do anything. Like my Wordle, my app component is not even taking a right answer, but it worked. And you might be thinking to yourself then, like, hey, was this test useless? And I think if you asked me that, like, let's say 2.5 years ago, I would probably feel inclined to look into the internal state of my app to make sure that my app is keeping track of the right answer that was given. And I strongly recommend you not to do that. You don't want your tests to be reading the internal behavior of your app. Treat your app as like a black box. And you're just, that black box is going to take a right answer, and then things are going to happen inside of it. And your tests don't care exactly what is happening inside of that black box. So is it a big deal that I wrote a test that passed right away? No. That test is still protecting that requirement of I should be able to give a right answer to this app. And as you're going to see like later down the line, we're going to keep building more and more requirements. And that's going to be driving our app. So I'm just going to continue here. What is next? I hope that if I try to give to that app a solution, like a right answer, that happens to have more than 5 letters, I want to see a warning showing up, right? So you can see over here, I'm going to create the app. I'm going to give a right answer that has more than 5 letters. And then I'm going to hope to see a warning showing up. So that's what I'm doing in here. Again, if you want to discuss the details of it, we can talk about it after the talk. But that's effectively what this test is doing. And if I run this test, it's failing. All right, so we're having an issue right now, are we? No, we're not. That's part of the process. We're expecting this sort of thing to happen. So what are we going to do then? We're supposed to show a warning every time the person gives a right answer that has more than 5 letters. Do you know what envelops that? Like what includes that situation? If we just show the warning every time, that is it. Every single time that you create our app, we're going to show a warning complaining, okay? And hey, that got the test to pass. Like, we're green. That was the least amount of work that I could have done to get that test to pass. And feels like cheating, right? Like, we wrote a test in there that was asking us to show a warning if you give more than 5 letters. And I'm just showing a warning every time. But this is exactly the mentality that I think developers should follow when they're doing test-driven development. You do the least amount of work necessary to get that test to pass. Oh, but it's not right. You're not supposed to be showing the warning if you're passing exactly 5 letters. And I agree. And that's why I'm going to go back and I'm going to make the previous test more robust. So instead of just saying, hey, my app should just not break if I'm passing exactly 5 letters, I'm going to update my first test and I'm going to say, if you pass a right answer that has exactly 5 letters, I should not see a warning showing up. So you see that? That quick implementation that I did to get test 2 to pass was good enough for the time. And always focus on that. You want to do the best implementation for right now. Don't try to think about the future. You know what I mean? The future is a concern of your tests. Think about the future when you're writing the test. What do you want to see happening soon? But don't think about the future when you're writing the implementation. Just think about the current test that you have. Does that make sense? So what I'm going to do now is that first test that we have, we're going to provide exactly 5 letters for the right answer. And I hope no warnings are going to appear. And I mean, as expected, this test is failing because we're showing the warning every time. So how can I get it to pass? Now I have to do a more real implementation, right? So for those who are familiar with Vue3 composition API, you can use define props, and then you can have a validator defined. And there you go. If I do this, if I have a validation over my props, I get my test to pass. And now we're in a green stage. And as we are in this green stage, this is the step for us to make our code to get to the refactor phase. And what is the refactor phase? The refactor phase is making the code easier to understand. So yes, go nuts. Like if you're in a red state, do whatever you can to get the test to pass. Like play dirty, like throw sand in the eyes of the code base. Like you can play dirty for sure. You want to get those tests to pass as soon as possible. And then you make things cleaner afterwards during the refactoring phase. So that's what I'm going to be doing right now. And if you want to learn about refactoring techniques, I strongly suggest checking out Woody Zhu and Llewellyn Falco talk about practical refactoring. it's sort of the scope of this presentation to be talking about refactoring techniques. I just want to give you like a very quick summary of this 2 hours presentation. You want to eliminate clutter, which is anything that is useless in your code base, like a code that is dead or comments that don't matter. Complexity, which is anything that makes the code harder to understand where it shouldn't. So if you have a function that is really large, or if you have magic numbers, those are examples of complexity. And cleverness. Cleverness is anything that on the day that you wrote that, you're like, wow, yeah, I totally understand what's going on. But as soon as like a month passes, even you can't quite tell what's going on in that code base, right? I can only speak for myself, but this has definitely happened with me before, where I do a solution and then I come back to my project after a few months and I don't know what I was doing there, but it works. That's an example of cleverness. And you don't want cleverness in your code base. Make it easy to understand, right? So in our example here, I'm just going to be reducing complexity. The number 5 doesn't mean anything. Like, what is the number 5, right? I don't know. But I could extract that magic number into a thing that just says, hey, by the way, for the settings of the game, this is the word size. Our words are going to be 5 characters long. There you go. So now it's easier to understand. I also, one of the things that Jest allows is for you to create describe blocks that have like tests inside of them. So I'm just describing the rules of setting up the game. So those 2 tests that we wrote, they are now part of this describe block. How can I set up the game? Those are the rules behind it. And with that, the refactoring phase is done. We can move on. Let's keep moving, right? One thing that I want to mention is I do like to use this feature that lots of test suite has. So for anyone who doesn't know, I mainly work with PHP for the backend and JavaScript for the front end, or TypeScript. And the test suites for both of those languages, they support this. I would assume this is very common, where you can write a to-do list in your test suite effectively. So I'm not actually starting to write those tests just yet, but I'm just reminding myself like, hey, things that I want this application to support eventually. But again, just keep that in mind. When I'm doing the implementation, I don't care about those to-dos. For the implementation side of things, only the tests that already exist matters. These to-dos over here are more like me reminding myself to write those tests, okay? So this is a very important thing to keep in mind. So yeah, now we're going to be setting up the tests for the rules of ending the game. So what I'm going to say is that I should not see ending game messages at the beginning of the game, right? So I'm going to create the app. I'm not going to do anything. And I hope that I'm not going to see winning or losing messages appearing on the screen. So this is the test that I wrote. One thing that I want to mention in here is that please notice that I'm not checking for exact messages. Like I'm not checking for like, oh, you should not see you win or congratulations. And the whole idea behind it is that the more specific in things that don't matter your tests are, the more fragile your tests are going to be. I don't want my tests to be clashing with people that are working in the app. If someone wants to change the winning message from you won to congratulations, the idea, like the spirit of that feature is still there. I don't want my test to be failing in that case. So instead of looking for an exact text appearing on the screen, I'm going to be looking for a message that has the idea of showing the winning message to the player. And that's it. That's the same line of thought that I follow to strongly recommend you to not be testing for CSS styling. That's only going to make your tests more fragile. If someone wants to move from flex to grid, your test should not be failing. That should be irrelevant for your test suite, right? So, and that test was passing right away, by the way, everyone. So as you can see the traffic light on the top right, that test was passing right away because the app doesn't have any winning or losing messages. So that's good. I don't have to do any work. I make my commit and I move on. So the next one is, if I guess it right, I should see a victory message appearing to the screen. So I'm going to create the app. The right answer is going to be tests. I'm going to type tests. I'm going to press enter, and I hope to see a winning message showing up on the screen. So to get it to pass, I just started keeping track of what the user is typing. And as soon as they press enter, I compare whatever the user typed with whatever they gave, like whatever the app was created with the right answer. And if they match, I show the message at the end. And this got the job done. Okay. And that's the point of that I showed in the slide earlier today, where if we type tests, we see the U1. Okay, so we have 4 tests right now. We have somewhat of a resemblance of a Wordle game, and we're just keeping it, making it better, right? So let's move on. Then I use this opportunity to organize my tests a little bit more, because now I am in a green state. So every test was constantly instantiating the app with a right answer of tests. I just moved that into a place that is going to run before all my tests. So I don't have to do this every time. Okay, the next one is if the player guesses wrong, I should see a fail message appearing. So it's going to be very similar to the right answer, but instead of typing something that is wrong, I'm going to, instead of typing something that is right, I'm just going to make a guess that is wrong. And I hope to see the losing message appearing. And again, this is failing, okay? A thing to keep in mind here is that, again, like, what is the least amount of work that I could do? And that's why I'm saying, like, just play dirty. Like, I'm just going to duplicate the logic that I did for the winning message. It's literally the same code. Oh, but you have duplicated code that doesn't look nice. No, it doesn't matter. I'm just going to get that test to pass as soon as possible. And by doing that, I got it to pass. So that's enough. I'm going to make a commit. And now I'm going to refactor. Now that I'm in a green stage, I'm going to be refactoring this code. And instead of keeping 2 variables to keep track whether or not the person won or lost, I'm just going to have 1 variable called game state. So it starts as in progress, and then when you submit your guess, it becomes either won or lost. And if you won, you see the winning message. If you lost, you see the losing message. And that allows me to, and you can see, like, if you run the tests, I have all the tests are passing still, because that's crucial for the refactoring phase. You don't want to be changing the behavior of the app. You just want to make it easier to understand. So if the app was passing before you started refactoring, they should still be passing after you finished refactoring. And all the tests are green, and look how fast they run, like 28 milliseconds to enforce those requirements. So that's good. Next, I'm going to write a series of tests that dictate the rules of the player input. One of the things that we need to keep in mind is that in the Wordle game, you cannot guess a word that is more than 5 letters. So what I'm going to do in here is I'm going to write a test where I'm going to type more than 5 letters, but just the first 5 letters are going to be exactly the right answer. So I hope to see the winning message appearing. So if you say on the test over here, I create the app, the right answer is going to be actor. I'm going to type actors, and I hope to see the winning message, because the first 5 letters make exactly actor. So they match. I should win the game. But right now I'm failing. So to get it to pass, every time you make a guess, I just consider just the first 5 letters of whatever you typed, and I get the test to pass. One quick comment that I want to make is my commit practices. I know it's kind of not totally related to what I'm talking right now, but I think it's important for us to keep that in mind. Because if you're following TDD, you always have a working app, always. And your app just keeps getting more and more feature complete as you go. But you always have something ready to deploy. If someone needs to deploy a Wordle game, I already have one at this point. So every single commit in this history has my app in a green state with all the tests passing. So when you write the failing test, the red test, I don't make a commit just yet. Then I get it to pass, and that's when I make commit. Boom, I have a commit right there. And then I'm going to make it a little bit easier to understand. That's another commit. A little bit easier to understand. That's another commit. And then I write another feature test that is failing. Don't commit just yet. So every stage in my commit history has this app in a passing state. Okay, so this is just a recommendation for you to follow. Next, the Wordle game. When you make a guess, Wordle only accepts real words for you to make a guess. So you cannot type gibberish. Okay, so to get this test to work, what I did is the right answer was supposed to be tests. I'm gonna try to type ASGFG, so just 5 letters gibberish. I'm gonna press enter, and I should not lose the game because the Wordle game should not consider my guess as a guess. It should just be like, okay, I'm still waiting for you to give your guess. So you can see that this test over here, I'm just trying to make sure that I don't see a losing message appearing on the screen. And this is failing because we are considering the losing message. So to get it to work, I just I went to a children's website and I just wrote a quick JavaScript to scrape the website for all the 5-letter words that they had. So they had like more than 2,000 5-letter words. I dumped a JSON, and so I just loaded this JSON. And effectively, as you can see over here, I'm just checking if the guess that you made is not included in the allowed words list. I just ignore your guess, and I keep waiting for you to submit a guess for me. And this was enough to get the app to pass. Again, like this was pretty quick to get it done. It's just a huge array with all the words. And if your guess is not in that array, I don't care. I'm not going to take your guess into account. And for refactoring, because at this point now, the rules of keeping track of the player input, they're getting more and more complicated. And up until now, I was doing the entire code just in one file. It was just in app.view. Everything was there. So now I decided to extract the stuff related to player input, and I've moved that stuff into a dedicated component. And this is what I'm doing right now. So all this chunk of code on the right side over here, they used to be inlined on line 30, right? So I just extracted that to make the code easier to understand. And here's what I think it's important. I did this massive change to my code base, but the tests are still passing. This is the beauty of your tests not knowing about your implementation. My test doesn't care if I have 1 or 300 components to make my app work, because my tests are not checking internal state. They're just checking what a player sees on the browser. So having tests that don't care about implementation details will allow you to freely refactor your code without having them fail. Okay. So next, I move on the. So in Wordle, there is no case. So there's no uppercase or lowercase. Your guesses are always in uppercase. So I'm just going to type an answer that is technically the right answer. Just the casing is different. I'm going to press enter, and I hope to win the game. And as you can see right now, we're losing because our game is case sensitive at this point. So to get it to pass, I just made everything uppercase. And there we go. The job is done right there. And okay, we are in a green stage. Our test suite is getting more and more refined as time goes, right? And at this point, for the refactoring phase, I looked into a chunk of code. Like there's 2 lines of codes that keep showing up over and over again in my test suite. And that is kind of like setting the value and then triggering key down dot enter, right? I can make that easier to understand because what's happening there is effectively just the player providing input. And I recorded a quick video over here of me doing that refactoring. And this is just a suggestion that I have because as you can see over here, I'm not exactly doing Command-C, Command-V. I'm just making use of my IDE to do the method extractions for me. Because humans make mistakes, right? Like I make mistakes all the time. So that's why I don't trust myself. So the more I can let a computer do the work for me, the better. So this is just a demonstration. I strongly recommend you getting used to deferring work for the computer as much as possible. PHP Storm is an amazing IDE for that. PHP Storm has a ton of refactoring tools built into it. And hey, you can get PHP Storm for free if you sign in for the Mark raffle that Margot was talking about. So there you go. I just quick plug-in over there for Mark Ruffalo. But effectively, after we extracted those methods, we went from this, which, like, you can understand what's going on in here, like you can, but there is a lot of view test to choose gibberish going on in here that doesn't make it super obvious. But by extracting a couple of functions, we went from this to this. And I think this over here reads more like English. I think even if you're not a software developer, you should be able to see what is going on in this test, right? And that's the idea. I just made my test a little bit easier to understand by extracting some methods. Okay, so again, strongly recommend that. That is on Woody's rules talk. They call this reducing complexity of the code. All right. Now I'm going to write a series of rules for displaying hints. And again, I love my to-dos. I just quickly think of stuff that I want to make possible, and then I go one by one from there. So I should not display the hints for whether or not the letter is in the correct place, incorrect place, or doesn't exist at all. So as you can see over here, I'm going to create the app. I'm not going to do anything, and I hope I'm not going to see correct, incorrect, or almost being assigned to anything in my app. So this is what the test looks like, and it's passing because nothing receives that, like, ever. So this is another test that is passing right away. And okay, it's good. And you can see that the entire test switch takes 50 milliseconds to run. But let's move on. Now, I hope that if the letter is in the correct place, I hope to see the app assigning a class to it that says correct. Note that I'm not going to be testing for the styling behind it. I'm just hoping that it's going to assign that class to it. And that's it. This is functionality, not styling. I don't test styling. So, okay, the correct answer is supposed to be words. And I'm sorry for my strong accent. I hope people are going to understand this. But it's supposed to be words. I'm going to type word. And so because of those letters being somewhat similar, the first three characters are correct. Both words have the same three characters in the beginning. So the first three characters should have the class of correct after I make my guess. But the last two should not. This is what this test is testing for. So if you know Vue, you can see over here, I just use bound classes from Vue to get it there. And this is what the app looks like right now. So the right answer was tests. So the first two characters are correct. And it's showing up marked with the correct class. All right. Okay, so that's some work was done. Moving on. All right. Now, I'm going to follow a very similar pattern for the other ones. So I'm going to use the same example of words versus world. And for the incorrect classification, I'm going to check for the letter L having incorrect. And for the almost correct classification, I'm going to check for the letter D having almost correct. So this was the correct test. This is the incorrect test. And this is the almost test. And they all look very similar. And you saw me doing this multiple times today where I identified some repetition and I extracted the repetition away. I removed the repetition. But I didn't do this for this one over here. Why? Because not all duplication is bad. Like, look at those puppies. Like, they're so beautiful. Like, not all duplications are bad. Like, sometimes if you look at your test switch, you need to think to yourself, is this duplication make my test switch harder to understand? Should I extract this into, I don't know, a generator function that is going to take what is the class that they're checking for and then does a dynamic comparison to know if the letter is going to have that class or not? I think that would make my test way harder to read than just having these three functions looking somewhat similar to each other. So no, I did not remove this duplication right here. I kept it in my test switch because I think this is one of those examples where it's not a bad duplication. Okay, so I just want to send that message. Not all duplication is bad. And so you can see over here that our app at this point has hints for all three types. So now there is bytes, wrong guesses, almost correct guesses, and perfectly correct guesses. Awesome. But there is still an elephant in the room, right? Which is in the Wordle game, you actually have 6 tries. And this entire time, I've been using just, you only have a single guess. You only have 1 try. And this was intentional. One of the skills that we develop as we practice more with test-driven development is this, and I still struggle with it, just to be clear, but like this is a skill that I try to get better every time, is being able to identify MVPs and then build on top of those MVPs. So for this Wordle game, the MVP that I identified was, let's get this Wordle game working with a single guess. And once we get the Wordle game working with a single guess, we can expand it to have 6 lives. So that's the point where we're going to have 6 lives. So, okay, I'm going to go to that test over here, and I'm going to pretend to be the player, and I'm going to fail my guess 5 times in a row. And then I'm going to look, like, do I see a fail message showing up in the screen? I shouldn't. And then I'm going to go and I'm going to make another failed guess, and only then I'm going to see a fail message appearing. So this is what the test looks like. And if I run the test is failing, as you can see. So to get it to pass, what I'm going to do is I'm just going to keep track of the number of attempts that the player has had. And if they happen to make a wrong guess and it's their 6th attempt, that's when I flip the game to the lose stage. And there we go. The test is passing. Let's celebrate, right? But if you, I actually caused another test to fail because of it. And this is another point that I want to mention, is that always run all the tests every time. Like you can see that the tests that we're running, like they take a fraction of a second. It's like nothing. Just keep running all the tests. Keep running all the tests. Don't just run the test that you just wrote, because your tests are going to be protecting you against regressions in your app. Okay? So yeah, that feature that I just did broke another test. And this is the point that I want to drive, that a test failure doesn't necessarily mean that your code, like the implementation side of things, is broken. Maybe that test is no longer relevant. So that's whenever you see a test failing, think to yourself, what's going on in here? And let's take a look. Like, what was the test that failed? Oh, it was that one test that was responsible for making sure the losing message would appear to the screen as soon as the player made one guess wrong. This test is no longer relevant. So you know what? I'm just gonna get rid of it. I'm just gonna delete it, because deleting tests is okay. I know that like this is a thing that I've seen before, and I'm definitely like I've done that before as well, where we get attached to our tests and we're afraid of getting rid of them. But I've used this picture over here of a scaffold, because that's exactly how you should see your tests. Like sometimes, like for you to make a building, you need to put this additional structure that eventually you're going to remove, right? Some of those tests are exactly that. As you're building the app, you're going to write some tests that eventually are going to get removed. So this was one of those tests. So I just deleted it, and my test switch is back to green. All the requirements that I want to enforce in my application are still protected by tests. All right. So at this point, for the refactoring phase, I went ahead and I've noticed that the part of the code related to showing the hints over the player guess, it was getting pretty large. So instead of having all of that chunk in my app, in my main app file, I've moved them into another file. And this was the second time that we've done that. And that's what I want to say. Like, don't try to think about the future. Like, I used to do this a lot, and I am strongly against doing that nowadays. Where in the past, I used to think like, hey, for this app that I want to make, I'm gonna need a component that takes the player input, and I'm gonna need a component that shows the hints. And then I would start my project by working on that component for the player input, and I would write the test for that component. And once that component was good, I would move it to my main app file, right? But I strongly recommend you not doing that. Always start by inlining the implementation. Just do the implementation right where it matters. This is part of doing the least amount of work necessary to get the test to pass. Just do it right on the file. And then during the refactoring phase, if you identify chunks of code that are cohesive for a given objective, that's when you extract them. But let those cohesive parts get to know each other naturally. Don't try to think ahead and think like, oh yeah, I definitely need to have that extra component. No, just leave them to naturally form in your app. And I did a quick testing here that like the input gets cleared up after the player makes a guess. This is just so you know. But again, I don't want to be diving too much into this. And this is the app that we have right now. So I can make my guesses and I get feedback over my last guess, but they're all building up on top of each other. Like if I make mistakes 6 times in a row, I lose the game. But I can only see my past guess getting feedback. So what I'm going to do is I'm going to write 2 extra tests in here where, just like in the Wordle game, I should see all the allowed attempts being rendered empty in the beginning. And then as I'm making attempts, I should see my previous guesses showing up. So to make sure that I can see all the empty blocks, I'm just going to create my app. I'm not going to do anything. And then I'm going to hope I can see 6 blocks for best guesses. And every single one of those blocks has 5 slots for letters. So this is what the test looks like. And it's failing. To get it to pass, I just did some V4. It's how you do loops in Vue. And that was enough to get the test to pass. And then I just used 2 tablespoons of CSS, and I've mixed it over warm water. And the app looks like this now. All right. So what I'm going to do next is, like, Wordle. Like right now, my game of Wordle accepts anything at all, right? Like I can type exclamation marks or whatever. So Wordle is supposed to accept only letters. So let's do that. So I'm just going to, acting as the player, I'm going to try to make a guess that has numbers, space, and exclamation marks. And then at the end, when I look at the guess, like the person, like when I look at what is in the player input, I want to make sure that it only shows AB in there. So only the letters are showing up. This is failing right now because my app is accepting everything. So to get it to pass, I just, oh, you can see over here, like I was hoping to see only AB, but I'm getting numbers, exclamation marks, and spaces in there. So I just brought the power of regex, those beautiful, beautiful regex. They get the job done, and that's it. I can move on. For the refactoring phase, there is a lot going on in my input sanitization. So I just extracted that into a method that says what is happening. And I've moved on. So there is one thing that is still not quite right in this app. Like I still have this ugly input field at the bottom of my app. But in the Wordle game, what you type show up exactly where you're gonna get your feedback. So let's address that. So what I'm gonna do in my test is that I'm gonna start typing a guess, but not fully finish it. And I'm gonna check the top view. And that top view should have exactly what I'm typing. Then I'm gonna continue, I'm gonna finish that guess, and I'm gonna start typing a second guess. Then I'm gonna look at the second to the top view. And that should have my new guess in it. So if I run this test over here, it's failing because I don't actually render those guesses to the screen at all until they are submitted. And if I'm not going to go into details about this implementation, but effectively, this is what I'm doing right now, that if it's the current guess that you're making, I'm just showing whatever you're typing. And that got the test to pass. But take a look at what happens now. So notice how even though I'm following test-driven development and I have automated tests, I'm still like checking the browser every now and then. But it's not like a requirement for every single time I need to check the browser. But I do some QA to see if what's going on in the app. And I identified 2 bugs in here, right? So one, we're getting feedback of our guess before we even submit it. And second, we're losing letters as we're typing. So this is what we call a regression test. Exactly, Paul. Exactly that, man. So because we identified those bugs, I'm going to write 2 new tests to my test suite that enforces like exactly this behavior. So if we take a look over here, I should not see the results or like the hints before I actually submit my answer. So I'm going to start typing great, 1 letter at a time. And as I'm typing that, I should make sure that there is no correct, incorrect, or almost showing up in the screen. And hey, this is failing as we expected, because that's the bug that we identified. So to get it to work, I just made an extra. My guest view now accepts a thing that tells you whether or not you're supposed to render the hints to the screen. That got it to work. And then I wrote the second test that it keeps the number of letter blocks consistent as the user types a new guess. And again, I'm just going to be looking into that guess view. And as I'm typing 1 letter at a time for the great, I should still have 5 letters showing up every single time in my view. And this test is failing because, as we saw, the letters all disappeared at the end. To get it to work, I just made a computed property. Don't worry too much about it. But effectively, I'm always showing empty spaces at the end of my guesses to always have 5 characters at the end. But that's it. This was enough to fix this bug. And this is what the app is looking like right now, right? Like it has like that bug is fixed. So at this point, as I'm making my guess shows up in the proper place, and my app is no longer spoiling the answer before I actually submit. So again, I left some CSS cooking overnight, add some salt, and after taking it off the oven, we got the app looking a little bit better. And this is the version that I've showed you at the beginning. But again, I did a lot of CSS work between the past slide and where we got right now. But I did not show you any tests related to that because they don't exist. I don't write tests from my CSS. So all these little dances and the colors that I'm using, those are not under test. Okay? That's the important point that I want to hit. So now, this is what we have in the app right now. We have 23 tests that runs in a fraction of a second that dictates the rules of the Wordle game. So someone coming to this project that doesn't know anything about Wordle, they can say like, okay, there are some rules for setting up the game. Oh, okay, the right answer needs to be 5 letters long. Oh, and when the player is providing input, it has to be a real word, and it's not case sensitive. Okay, that is cool. And in hints, letters that are in the correct position show up with the correct class, or letters that are not present in the word shows up with the incorrect. This is explaining the rules of the app for someone who doesn't know what Wordle is. So that's what I mean with a strong test suite acting like documentation. So in short, the tests acted as 3 different roles. They acted as a planning resource, as I was thinking like, hey, what would be a feature that I would like? And then I write that test for that. And then once I started actually trying to get the test to pass, the test becomes my coding buddy. So they're just saying like, hey, just do the least amount of work necessary to get me to pass. And as I try, my test says, it's not good enough yet. It's not good enough yet. Keep trying. And as soon as I get something that gets the test happy, the test lets me know right away, okay, you're good to go. And then I make a commit. And then my test continues to be beside me to help me make that code easier to understand. Again, just saying, yep, it still looks good. It's still, oh no, that change that you did, that feature is no longer working. So that's what I mean by having your test becoming a guide. And then once I move on from that feature, I can leave the app entirely, like leave that group of work. But those tests are now acting as guardians of those requirements that they help implement. So someone coming into this code base months in the future, those tests are gonna be protecting any future implementations from breaking those implementations. Okay, those features, and that's it. This is pretty much the talk. I just wanted to show the overall flow of what it's like to create an application with test-driven development. Again, if you're curious about discussing Vue 3 composition API or Vue test utils, I also like working with Laravel. So if you're into PHP or PHP unit, hit me up. I'm more than happy to talk. You can also see over here, my GitHub is frflor, so it's my name. A Wordle on TDD, that's the project. You can check it out. The full source code is there. And this is my email as well, if you want to reach out. But that's it. Thank you so much for watching.